Hello everyone, my name is Chris Gangananta. I'm a sales engineer at Opal Technologies. Today I would like you to welcome to our little demonstration for the Opal learning journey. We're going to be seeing a microgrid model running on our OP5707XG platform, which is interacting with a Cell 421 delay to do a full HL setup for the protection scheme. The specific model in question is the Ghost model, which has 3 feeders, feeder 1, 2, and 3, which is connected to an utility service running at 150 kilovolts at 60 hertz. We also have in each feeders different DERs. One of the DERs in feeder 1 is actually a diesel generator. The feeder 2 has 2 DERs, a battery and a PV, and that's where we're going to be applying a fault and see how the relay reacts to that specific fault. And feeder 3 has a CHP inside. The hardware platform is going to be basically an OP5707XG platform, which is sending through analog output a low voltage to a PT and a CT of the Cell 421 relay. When the Cell 421 relay, it's sending back a signal to our simulator to close the circuit breaker through the means of a 650 goose message. All this is running in HyperSim in a real-time environment in EMT, and we are able to interact with HyperSim and ScopeView through the means of a LabVIEW panel that we're going to be seeing. Now we're going to be seeing scenario 1. So scenario 1 is when the model is running in grid connected mode. So as you see in the model, we can see the feeder 1 and feeder 2 and feeder 3, the breakers are closed. That means that it's connected to the grid and it's running in grid connected mode. We also notice the battery and the PV being very stable, and we also see the frequency of the battery being around 60 hertz. Next, we're going to see how the grid side measurements looks like from the grid's perspective. So as you can observe, the voltage and the current are in steady state, which is a good thing for stability. Then if you take a look at the feeder 1 measurement for the DG, we see the active power and the reactive power being stable. We also see the frequency being around 60 hertz. For feeder 2 measurement, the active power and the reactive power of the battery are very stable, and the frequency also being around 60 hertz. For feeder 3 measurements, we have the CHP active power and reactive power being very stable, and also the frequency being around 60 hertz. Now we're going to be applying the fault on the HyperSim model. So we're going to be applying the fault at the specific box right here, and we're going to see the relay detect the fault and the changes in the bus voltages and tripped and consequence. So as you see, we are applied the fault phase A, B, C to ground, and we're able to see the effect on the simulation in consequence. Today we saw our microgrid ghost model running on our HyperSim EMP simulation software. This was running on our 5707XG platform and interacting with the Cell 421 relay through the means of analog output. In consequence, the relay was sending a goose message back to the simulator to be able to close the circuit breaker. This shows us a full HL setup for our protection scheme scenario. We hope that you enjoyed this demonstration, and please visit us at opalrt.com to learn more about our solutions.